We're going to find the domain and range of a function from its graph. Remember that the domain of a function are all the possible values for my input, for my x. So to find the domain of a function from its graph, we're going to look at where the graph starts and where it ends in the horizontal direction. Remember, when we're talking about an interval over the real numbers, we always go from left to right. So we're going to be looking at where this graph starts on the left side and where it ends on the right side horizontally. Okay, so let's look at this graph. It looks to me like this graph starts right here. And it looks like that point is -2, 0. So the graph is starting in the x direction at that point. It looks like it's ending right there. And it looks like that point is what, 1, 3? So the graph is ending at the point 1, 3. So it's ending in the x direction at the point 1. Now also notice that each end of this graph has solid dots. When we have solid dots, we include the endpoints in our domain and in our range. So the domain of this function are going to be all the values for x such that x is greater than -2 and x is less than 1. So x is between -2 and 1. So how do we write that? Well, in set builder notation, we write the set of all x's such that, and we write exactly that x is greater than or equal to -2 and less than or equal to 1. Now, again, we have solid dots, so we're including those endpoints in the domain and range of our function. So since we have a solid dot, we're going to have equality. All right, how do we write this in interval notation? Well, this is the interval that goes from -2 to +1. So in interval notation, we just write -2 to 1. And again, since we have solid dots, we use brackets. All right, the range of a function are all the possible values for y. So we look at our function in the vertical direction, and we look for the smallest value of y to the largest value of y. So looking at this function's smallest value for y, smallest value in the y direction, is 0. The function goes vertically up to the point 3. The largest value for y on the graph of this function is 3. So our range is going to go from 0 to 3. Again, we have solid dots, so we're going to use greater than or equal to, less than or equal to, and we're going to use brackets when we write it in interval notation. So the range of this function in set builder notation, again, we're talking about range, so we're talking about y values. It's the set of all the y's such that what? Y is greater than or equal to 0, and it's less than or equal to 3. So in interval notation, that is the set that goes from 0 to 3. Again, solid dots, equality, brackets. All right, so let's look at another example. Let's look at this one. Now in this example, we have an open circle at the beginning of this graph in the x direction. Since we have an open circle, that means we're not going to include the point. What is that point? That's the point -2, 2. We're not going to include that point in our domain or in our range. Okay, so let's look at this point here. This point looks like to be what? 1, -1. So let's talk about the domain. So again, the domain of a function is all the possible values for x. So it's where the graph begins and where it ends in the horizontal direction. So this graph is beginning at -2 and it's ending at +1. So the domain is going to be all the numbers between -2 and 1, not including -2. So how do we write that? In set builder notation, that is the set of all the x's such that, well, x is going to be greater than -2 and less than or equal to 1. Again, since I have an open circle at the point -2, 2, I do not include -2 in the domain of my function. So I have just greater than, not greater than or equal to. So when we write this in interval notation, we're going to use a parenthesis next to -2 because we're not including that point in our domain. And we're going to use a bracket at 1 because we are including that point because we have a solid dot at that point. All right, what's the range of this function? The range of a function are all the possible values for y. So again, we're going to look where is the smallest value I have for y, and we're going to go to the biggest value for y. Range goes from smallest y to biggest y. So if we look at the graph of this thing, it looks like my smallest y is -1. And my biggest y is -2. Or excuse me, +2. So now I can write the range of this function. The range of this function in set builder notation is all the y's such that we're going to start at -1 and we're going to end at 2. I'm going to include equals on the -1 because I have a solid dot at the point 1, -1, so I'm going to include that point in my range. But since I have an open dot at -2, 2, I'm not going to include 2 in my range. So in interval notation, this is all the values for y between -1 and 2. I'm going to use a parenthesis on the number 2 since I have an open circle there. That point is not included in my range. But I am going to put a bracket on my -1 because -1 is a solid dot, so I'm including that value in the range.